Okay, in this video we are learning how to dilate a figure from a point that is not the origin. In order to do this, we have to find the slope, which is the rise over run. It's the difference of the y-coordinate divided by the difference of the x-coordinate. And so we're going to do it two different ways. We're going to use counting, and then at the bottom we are going to use our slope formula. So the first thing we can see is we need to figure out the slope for A. Remember, slope is represented with an M. So from B to A, we're going to see that our rise, our top, is going to be 1, 2, so a negative 2 on top. And then we're going to see that we moved 1, 2, 3, 4, 5, so a negative 5 on bottom. Okay? Now, because we have the scale factor of 2, which means that since our k is greater than 1, we should get an enlargement or a bigger picture. We're going to multiply both the top and the bottom of my slope here by 2, so that I get negative 4 over negative 10. Now, the reason I'm not converting this to a positive is because I want to know which direction I'm going to move in. So by keeping it at negative 4, I know from B I'm going to go down 1, 2, 3, 4. And then I'm going to go to the left 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And that's where my A prime is going to be at, which ends up being A prime is located at negative 7, 1. And if that's it. We're going to do the same thing for C. So M equals, from C to B, we go down 1, 2, 3, so our slope is starting at negative 3, and then we go over in the right direction a positive 1. Again, multiply both by 2, so that we get negative 6 over 2. And so now we know that we need to go down 1, 2, 3, 4, 5, 6, and then over 2, 1, 2. And we have our C prime, which our C prime ends up being 1, 2, 3, 4, 5. So positive 5, comma, negative 1. And that's how we use slope to find our new picture dilated around a certain point. So here is our giant triangle. I'm sorry for the squiggly lines, but notice our triangle got bigger. Now down here at the bottom, we see that we have a dilation factor of 1/2. So let's circle what we're talking about. We're dilating around point X and point B, so we should make sure that we notice that. But down at the bottom, our dilation factor is less than 1. So I should write reduction. So my picture should get smaller. Again, up here we had an enlargement. So my picture should get bigger. This is easy ways for y'all to check, guys. Okay? And gals. Okay? So scale factor of 1/2. So we're going to do the same thing. This time we're going to actually calculate the slope. So we're given the x point. So slope is equal to the difference of my y's, so y2 minus y1, over the difference of my x's, so x2 minus x1. And so in this case, I'm going to have my y point be my first point, or my second point, and my x be the other one. So I have 0 minus 6 over 2 minus 6, and when I do that, I get a negative 6 over a negative 4. Now I need to multiply this by 1/2 because that's my scale factor, or divide by 2, and when I do that I get negative 3 over negative 2. So from the point X I need to go to the left, I need to go down 3 and then left 2. So I'm going to go 1, 2, 3 down and then left 2, 1, 2. And so that's my X prime. And so, or sorry, not my x prime, my y prime. So y prime is now located at 1, 2, 3, so positive 3, and then, where's the positive 4? Positive 4, sorry, I miscounted. So we have 1, 2, 3, 4, 1, 2, 3. So we're at positive 4, positive 3 for my y prime. Now, we do the same thing for z, so again, m equals y2 minus y1 over x2 minus x1, which means that this is going to become 2 minus 6 over 8 minus 6, which means I end up with negative 4 over 2, and I need to multiply both of those by 1/2, so I get negative 2 and 1. So I need to go down 2 and over 1 to the right to get my z. So if we go 1, 2, 1, my z prime is there. So I have a y prime and a z prime there. And so the coordinates of my z now are 1, 2, 3, 4, 5, 6, 7. So we're at z prime is 7, comma, and then 1, 2, 3, 4. So 7, comma, 4 to get our new coordinates. And as you notice, if I draw the triangle and connect my dots, it's a little hard to see, but if I connect my dots, we see that my triangle did get smaller, which means we did reduce it.